I'm glad to inform you that I have just published a monograph called Beyond P less than 0.05 Scientific Inference in Accounting Research. The p-value is a standard statistical tool used for making inferences in the sciences. We formulate a null hypothesis and then we calculate the p-value. If it turns out to be less than 5%, then we say that the null hypothesis could not be true, or at least the probability of the null hypothesis being true is less than 5%, so we can reject it and accept the alternative. This is actually a misconception. P-value does not tell you about the probability of the null hypothesis, and yet researchers have gone ahead and used and overused and misused p-values, which has led to a reproducibility crisis in science. A recent project that sought to replicate 100 prominent studies published in the top psychology journals found that less than half of those studies could be replicated. That's the extent of the problem. The American Statistical Association issued an advisory that said that p-values should not be solely used for scientific inference or for policy decisions. So if you cannot use p-values, what do you do instead? That's what the monograph is about. And the answer given and elaborated in the monograph is based on the fact that we human beings have good intuitions regarding inference. We have been told the opposite, so you might not believe me, but consider the following example. Suppose I tell you that I have a hypothesis that people in an ancient civilization used shawls. Then I went to the ruins and actually found rectangular pieces of cloth. So therefore, I say my shawl hypothesis is proved. You will immediately object, saying, no, not so fast. Those rectangular pieces of cloth could be something else. They could be a turban, they could be a tablecloth, etc. On the other hand, if I told you that my hypothesis was that people in the ancient civilization used gloves, and then I went there and found these pieces of cloth in exactly the size and shape of the human hand. Therefore, I say my glove hypothesis is proved. You will accept my conclusion. What is the difference between the first example and the second? The answer is that in the first example, what I found, rectangular pieces of cloth, is explainable by several other things other than my shawl hypothesis. On the other hand, in the second example, it is hard to explain the presence of something in the size and shape of the human hand if it is not a glove. This aspect, which we intuitively do consider, however, is not part of the standard null hypothesis testing using p-values. In my monograph, I developed the implications of this approach to inference. It is not new, it is intuitive, and it is something that has been used by researchers all along, used by the best researchers all along. But a systematic exposition of these good inference practices has not been available so far. So I provide such a systematic exposition. I give plenty of examples to make it easy for readers to follow. The reviewers of my monograph told me that there was something useful in it for researchers at all levels. although it is aimed primarily at doctoral students. So with this monograph, I hope to improve the quality of scientific inference in accounting and other areas of business research.